The vision of SpaceX for Moonbase Alpha is going to redefine who truly leads the next space age and also why the US might be able to pull decisively ahead of Russia and China. But before we get into it, don't forget to subscribe to our channel for more moon-based mission breakdowns. Why the moon matters again. The moon has hovered in our collective imagination for more than half a century, not for what it is doing, but as a symbol of what humanity can do. The lunar surface went silent after Apollo 17 in 1972. No more voices, no more boots, and just dust or shadows. But that silence was never permanent. It was just delayed due to politics, budgets, and technology that were not able to catch up with the ambition. Today, the moon matters again because it can solve multiple problems simultaneously. It is close enough to the Earth to be reached in days and not months. It is rich in untapped resources, and most importantly, it is the ideal ground for proving long-term living beyond Earth. If humanity has the desire to expand further into the solar system, then the moon is not optional, it is actually essential. China and Russia have both announced plans for lunar research stations, resource attraction, and long-term robotic operations because they understand this. But SpaceX, which is working alongside NASA's Artemis program, is going to approach the moon with a radically different mindset. Their thinking is about speed scale and reusability, which is a difference that may define who truly owns the next chapter of space exploration. From Apollo's footprints to a permanent presence. The Apollo missions are technically considered the ones to establish the first bases on the moon. They started with Tranquility Base in 1969, but calling them bases is actually being generous because they were only short-term camps where astronauts lived inside lunar models for a few days maximum. They conducted several experiments, collected some samples, and left before supplies ran out. The longest surface mission was Apollo 17, which lasted just over 3 days. Astronauts encountered one of the moon's most underestimated enemies during that time. That enemy is lunar dust. It is fine, abrasive, and electrically charged, which seems alive. It clung to astronaut suits, tools, and their lungs. Astronauts reported smelling it inside the cabin, and it was like burned gunpowder. That dust caused eye irritation, breathing issues, and mechanical wear. It all happened during the missions that barely lasted a weekend. A permanent base should solve the problems that Apollo had to face, and also those problems that they never faced. Everything from radiation exposure, muscle and bone loss, psychological isolation, dust infiltration, thermal extremes, to micrometeorite impacts must be solved because the moon does not forgive shortcuts. That is why Moonbase Alpha will not be an upgrade, but it will be a complete rethinking of how humans are going to live beyond Earth. SpaceX's radical idea: let Starship become the base. Building a traditional moon base from scratch would normally take decades, including hundreds of launches, massive budgets, and complex international coordination. But SpaceX skips most of that part by asking one simple question: what if the spacecraft itself is the base? This fully reusable heavy-lift vehicle by SpaceX is called Starship, which was designed from the start for long-duration missions to Mars. This means it has life support, volume, structural strength, and redundancy already built in. Its internal volume alone could exceed that of the entire International Space Station, and that is the size before you repurpose the fuel tanks. They are planning on using Starship's emptied methane and oxygen tanks as pressurized living and working spaces for Moonbase Alpha. They are constructed with stainless steel, making modifications easier than traditional aerospace materials. This cylindrical geometry is also ideal for habitat conversion. Instead of landing, unloading, and leaving, Starship will stay and become a home for astronauts. This approach gives SpaceX a massive advantage over Russia and China. While their plans rely heavily on modular launches and slow assembly, Starship will deliver everything in one go, including structure, shielding, transportation, and expansion potential. Why the lunar South Pole changes everything. The big evolutions in Moonbase Alpha are not just about the hardware, they are also about location. The chosen site is near Shackleton Crater at the lunar South Pole, which is one of the most strategically valuable places in the entire solar system. The crater's rim receives almost constant sunlight, which solves one of the moon's biggest problems of power. Meanwhile, the crater's interior remains in permanent shadow, which creates cold traps where water ice may have accumulated over the past billions of years. Data from lunar orbiters has strongly suggested frozen water beneath the surface, as they already detected high hydrogen concentration. Water availability will change everything. It means from drinking water, breathable oxygen, to rocket fuel, everything will be produced locally. These detections alone will reduce mission costs by orders of magnitude, while it also means sustainability for this mission, which no previous lunar mission has ever achieved. Russia and China have also identified similar regions on the Moon, but space accessibility to land massive payloads with high-level precision will give it a decisive edge. Having access to water alone would not be enough because you will also need the infrastructure to use it. The two Starship strategy. This is where the two Starship strategy begins. Moonbase Alpha will begin with a coordinated dual Starship mission where one uncrewed Starship will be launched first. It will be packed with tools, robotic systems, construction equipment, power units, and supplies. Soon, another spacecraft will be launched to follow it. This Starship will carry astronauts, life support systems, and additional rovers. Both vehicles will rendezvous in Earth orbit for refueling before heading to the Moon. Once they reach there, they will land at least 5 kilometers apart to avoid any kind of accidental damage from landing debris. It is a lesson that was learned from decades of lunar simulations. The crewed Starship will act as a temporary habitat during early operations, while over the next 2 to 3 months, astronauts will oversee the transformation of the uncrewed Starship into a permanent base. They will rely heavily on robotics for this, as this is not 1969 anymore, and humans don't have to dig trenches by hand. If you are enjoying this deep dive video, then make sure to subscribe to our channel for more space mission breakdown videos. Turning a rocket on its side. Starship will land vertically on the Moon, but we all know living in a vertical rocket is not practical in the long term. The solution here is to lay it. Robotic rovers will assist in carefully tipping the vehicle into a horizontal position, where it will be stabilized between regolith berms to prevent any kind of rolling. Remaining fuel will be drained before turning the rocket, and it will be stored for reusability. Internal pressure will be adjusted, and the structure will be prepared for long-term habitation by the robots, and humans will only supervise them. Hatches will be converted into tank domes, floors and walls, and insulation will be installed to make the life support system online. A spacecraft will slowly and methodically become a settlement when lights replace all the darkness. One of the most symbolic features of this craft is its observation deck, which is positioned to face Earth. Because even when Earth is on the Moon, perspective matters. Burying the base for survival. Once the interior transformation is complete, the entire structure will be buried under roughly 3 meters of lunar regolith. This is not something cosmetic, it is survival. The Moon is constantly bombarded by micrometeorites. These tiny impacts happen thousands of times per day because, without an atmosphere, there is nothing to slow them down. So this regolith will help in shielding by absorbing these impacts while also protecting against radiation and extreme temperature swings that shift between -75 degrees Celsius at night and degrees Celsius during the day. This simple solution of covering the base in moon dirt is brutal enough to outperform many high-tech alternatives. Also, it is local, scalable, and effective as well. It gives Moonbase Alpha a durability that few other concepts can match. The dust problem no one can ignore. Lunar dust is still one of the biggest threats to long-term habitation as the particles are quite sharp, electrostatically charged, and small enough to lodge deep in the lungs. This exposure could lead to chronic respiratory conditions and kidney failure over time. Moonbase Alpha planned to address this with a layered defense system. This includes advanced THISKs with enhanced shields, electrostatic dust removal systems, and strict suit donning and doffing procedures, along with continuous air filtration and monitoring. Russia and China face the same challenge, but SpaceX is benefiting from decades of ISS life support data and modern materials sounds. Dust is not just a nuance anymore. It has become a system-level problem, and it needs a system-level solution. Life in low gravity. The Moon's gravity is just 1/6 of Earth's. That is great for jumping around, but also terrible for human biology over long periods, because humans have evolved to live healthy lives on Earth with its strong gravity. Astronauts can face bone density loss, muscle atrophy, cardiovascular decline, and neurological changes, and all of these are real risks. To address these problems, Moonbase Alpha will integrate structured exercise as a core system instead of an afterthought. From resistance training, aerobic workouts, high-intensity intervals, to plyometrics, everything will be included as essential. Group exercise sessions will also be added to serve a psychological purpose while reinforcing routine, boosting morale, and improving team cohesion. This type of approach is what makes a permanent basis different from short missions. Because survival is not enough, performance also matters. Radiation, the invisible threat. The exposure to radiation on the Moon is roughly 2.6 times higher than on the International Space Station. Solar storms can spike those levels dangerously within hours. Acute exposure can impair cognition, damage organs, and end the entire mission instantly. This is an invisible threat that can't be seen on the surface with the naked eye, but it exists. And Moonbase Alpha relies on regolith shielding, real-time radiation monitoring, and strict racial limits to combat this threat. Emergency shelters within the base will allow astronauts to reach safety in below 30 minutes if solar access is lost at any time. China and Russia are studying similar systems, but again, scale matters. A larger buried habitat can offer more protection than smaller modular stations. Powering the base and sustainability. Power is the backbone of everything in all these moon missions. Near continuous sunlight at the South Pole will enable large solar arrays, but that's only a single part of the equation. Fuel cells using hydrogen and oxygen will provide backup power while producing water as a byproduct. This is like hitting two birds with one stone. Nuclear fission reactors will also be present on the table to serve as small, self-contained systems that are also capable of running for a decade without human intervention. They could supply consistent energy regardless of lighting conditions. This reliability is essential for long-term survival. Water is definitely priceless in space, and transporting it from the Earth costs staggering amounts, which makes local extraction critical. If lunar ice is accessible at scale, it will become the foundation of a closed-loop system including drinking water, oxygen, fuel, and agriculture. Food presents an even tougher challenge. Early missions rely on dehydrated supplies, but long-term habitation will certainly demand local production. Experiments have already shown plants can grow in lunar soil with some limitations. Genetic adaptation, soil conditioning, and nutrient recycling will be the next steps for producing food on the Moon. Russia's plans are constrained by aging launch systems, while China's approach is methodical but slow because they focus heavily on robotics. SpaceX's advantage is scale, speed, and reuse. Moonbase Alpha is not science fiction anymore. It is an achievable step toward a permanent human presence beyond Earth. If you enjoyed watching this video, then do subscribe to our channel for more incredible, innovative, technological breakdowns.